Hello, PreCalc. It's November the 8th edition, and we are watching this after class on November the 8th or November the 9th, so whatever works for you. And you need to have seen this by the time Thursday's math class comes around. And we're going to look at solving trig equations again. And there's not a whole lot left in our study of trig equations, so let's see how this one goes. I'd like to go over a problem like this, and I think it'll catch the complication. We always add a certain complication every night. So this one will catch our complication for tonight. Secant squared x minus 2 tangent x equals 4. So write that one down and look at it intelligently and tell me what complications you see that you've already addressed before. Well, one thing you're seeing is secant squared and tangent squared. There's two different trig functions. So we want to change that so we're either working in secant or in tangent. So which one should it be? Well, let's see. I'm going to grab somebody's thought cloud. Whose thought cloud did I grab? I grabbed, my goodness, look at that. It is Bree's thought cloud. All right, Bree, thank you. So as you notice that from our trig IDs, that tangent squared x plus 1 equals secant squared. It's one of the Pythagorean IDs, and we can represent secant squared with tangent squared x plus 1. And when we do that, we are representing secant squared x, and now we're here to the minus 2 tangent x from the problem, and equals 4. Alright, let's move the 4 over, set everything equal to 0, and combine like terms. So we have tangent squared x plus 1 minus 2 tangent x minus 4 equals 0. What like terms do you see? Tangent squared x plus, I'll put in this term x, minus 2 tangent x, and a plus 1 and a minus 4 give me a minus 3. Alright, how do we solve the trig equation when we get down to this point? When there's 3 terms like that, and you can't take out anything common to all 3, what should we do? I'm going to grab another thought cloud, and this one is Ryan, because Ryan is ready. He has observed that when there's a trinomial, 3 terms like this, and one of them squared, you're going to factor it like a trinomial in algebra. And so, thank you, Ryan. So we're going to put an expression here and here that multiply together to give you tangent squared. So that's going to be tan, tangent x. And now we are going to multiply whatever's here times here to get minus 3. So we can put in a minus 3 and a 1, or a plus 3 and a 1, minus 1. So I'm going to use a minus 3 and a plus 1, and I check the inner product, it gives me minus 3 tan, and the outer product gives me plus 1, and that adds to give me minus 2, so it's totally factored. Alright, so let's go ahead and take each branch. Tangent x equals 3. When I set it equal to 0, I move the 3 over, and tangent, oops, we have an undressed tangent. Tangent x equals minus 1. Alright, these 2 branches will lead us to all the answers, but where is there on the unit circle a tangent that has, which means the second coordinate divided by the first gives you a 3. I don't think so. It doesn't exist. You can test all of the sixths and all of the quarters and all the monkey math, and tangent x, second coordinate divided by the first, is never a 3, just never. So this is our complication for this evening. What do you do when the last step brings you to a function where it doesn't give you a quantity on the unit circle? Come on. So what we do is we say there is an x that has this as its tangent, and the way we write it is we say arctan of 3, and we stop right there. Well, almost. We have one more step, but this is saying I'm talking about the angle that has this as its tangent, and that's what we were looking for. The angle that had 3 as its tangent. Another way to say that is the arctan of 3, or tan to the minus 1, read tan inverse of 3. So when I do that, I realize that the period of a tangent function is pi, so I can grab the infinite more answers by saying arctan of 3 plus pi n. Pi because that is the period of the pi of the tangent curve. You look back on our sketches in the past of tangent, you'll see that the tangent curve has a period of pi. So to grab all the other ones in each snake that have a tangent of 3, we're going to add pi n. Alright, so that's one side. Over here, it works pretty normally. Where is there a value on the unit circle that has, does that unit circle show up? If not, you can hear me talk about it. The unit circle, we're looking for a second divided by the first that gives us negative tan. So negative 1. So right here, pi, 1/4 pi, 2/4 pi, 3 pi over 4. We'll do that. And so will this one. And that is 4, 4 is pi, 5, 6, 7 pi over 4. And when we do that, we get the rest of them. Actually, we can take the first one and just add what? Each time to generate all of the answers in this unit circle that are indicated. We can keep adding pi n times. Alright. That's all I want to show you tonight, and your work tomorrow will have some that end like this, so be ready to impress me by remembering it and putting it to work for you in your classwork. So till then, good night.